this puzzle is the first one on this sheet of lots of puzzles. And I want to show it to you because now I can. Yeah. So we have 4 squares inside a rectangle. What's the angle? I implore you, do not watch this video. First, think about this problem. It took me weeks to solve it. I'm not exaggerating. But there's something about these puzzles that, you know, there is this sweet spot. Some problems are so hard you cannot do that. That's frustrating. And some problems are so easy, they don't present a challenge. Therefore, they're boring, kind of. And in between, there is the sweet spot when a problem challenges you, but you overcome the challenge. And for some reason, these Catriona puzzles have been like that for me. So I want to encourage you to think about these problems long and hard before you watch these videos. Maybe it would be best if by the time you're watching this video, you have a better solution than what I'm about to show you. The woman who creates these problems, her name is Catriona Shearer. She has some followings on Twitter, and they throw in lots of solutions, different ones for the same problem. All right. That said, let me try to get the picture right. Actually, this is going to be a tough one. It's amazing how many different ways can she put squares into a rectangle. All right, and so we're asked, so we have 4 squares arranged like so in this rectangle. And it looks like all 4 of them is one way or another interact with the rectangle in a significant way. I don't see extra information, not yet. And we have to find an angle, but that angle is interesting. We start from this point and we connect this point and this point. So there is a straight line, not in this picture, though. Close, but not. So I'm cheating a little bit. And what we're asked about is this angle. I thought weeks about this problem, and what I ended up was finding this angle. Well, of course, then you can subtract it from 90 and find that angle. So let's just say that we're going to be looking for this angle here. I looked at this thing. I drew lots of circles, all kinds of different circles, Thales circles, to no avail. And finally, I got lucky when I thought about the fact that this point here is equally far from this point and this point and this point. For obvious reasons, right? This is the length of the side of the square. And so I thought, let's draw in this circle, which happens to be the Thales circle of this line segment, which is why this point is also going to be on it, right? This is Thales' theorem. If you draw the Thales circle for a line segment, then every point on that circle will give you a right angle, and all those right angles are there. Now, why is this point on the circle? Because this is a right angle connecting to the 2 endpoints of this diameter, right? So that meant that this point is also on the circle. So now we have 1, 2, 3, 4 points on this circle. Aha, here it is. Consider this little arc here. What is the central angle belonging to that arc? Well, it's this. But that is clearly 90 degrees. So the inscribed angles belonging to the same arc must be half of that, 45 degrees. Well, at this point, there it is. You see? So this angle here is 45 degrees, and that means that this other angle here is also 45, which means this other angle here is also 45. And now looking back, it looks kind of obvious that, yeah, this looks like the isosceles right triangle. But you have to draw a lot of circles like that, futilely, for no avail, until you stumble into the one that works. And notice that none of this thing here was really necessary, I guess. See, this is just floating in air. It would be another interesting question, like what were the necessary conditions for this scenario? But here it is, the answer is 45 degrees. Thank you for watching.